Hey, so in this video I'm just going to be covering esterification, carrying on the few videos that I've been doing on reactions of alcohols, and yeah, so just covering esterification. Now, just to note, I'm going to show you what exactly an ester really is. It's an organic compound that contains the COOR functional group, and really R here just represents the alkyl chain, and the thing about esters is they smell quite nice, so they have a nice taste, and so they're used quite a lot in the manufacture of foods, and they're even used as sort of powerful solvents as well. So I'm going to just draw an example here of an ester, just using displayed formula to show you the best example. So we can see the double oxygens there that I've drawn, just filling in the hydrogens. Just filling in the hydrogens here. And this is what we call an ester, and really the ester bond is this part right here. And how we'd name something like this. How we'd name something like this is this would be called, let's look at the alkyl group, 1, 2, 3, let's fix that up. Propyl, and here we have ethane. Well, we have 2 carbons, part of the ester bond, so we have propyl ethanoate right here. And that's sort of how you should go about trying to name these esters and so forth. So esterification of alcohols is really given as this simple equation of an alcohol plus a carboxylic acid reacts to form an ester plus, see, water. So I'll give some examples here. The formation of an ester is actually this is a reversible reaction, and the forward reaction is condensation. You may have heard these terms from biology. And the backwards reaction is just hydrolysis, where you add the water again to form the carboxylic acid and the alcohol. So typically a few drops of a concentrated sulfuric acid are added as a catalyst, and it's usually held in sort of an 80-degree water bath. So I'll just give you a quick example here of what I mean. Say we have ethanoic acid. Here, I'll draw it out. Ethanoic acid. And then, say we have maybe some methanol. This is in a different color. This is our alcohol. We have some methanol. C like so. And these are going to react. So sorry, we'll draw it down here so we can see all our products. These are going to react with some H2SO4 and maybe 80-degree water bath, and they're going to form an ester. And when looking at an equation like this, just look for the O, H, and a H, because what is taken out of such reaction? A molecule of water. So we're going to take out one oxygen and two hydrogens. So really, what we're going to be left with is this CCOO with an O going back to the CC, carbon-carbon. And so we have this removal of this hydrogen and this O and H. Thus we form our ester, ethyloethanoate. So hopefully that was a good basic insight into esterification of alcohol. I will be going into some more details naming esters and then going into some more alcohol reactions. I think there's two more that I want to cover. Also, thing to note that working on large scale, the reaction mixture is continually distilled to collect the ester product. It's much more professionally done, just to try and increase the yield of the ester. Well, yeah. So hopefully you enjoyed this video. It's quite short, but it's just a basic introduction into esterification.